Right, hello class and welcome to CSC 321 Advanced Level Programming Language C++. Today we are going to see how we work with statements and flow control in C++. Okay, a simple C++ statement is an individual instructions of a program. Example, variable declaration and expressions that end with semicolon. A program may repeat segments of code or take a decision and split. The statement may either be a simple C++ statement such as single instruction terminated with a semicolon or a compound statement. For example, you may have something like beginning, that's the curly bracket, statement 1, statement 2, statement 3, and it goes on like that. Okay. Apart from this, we may have something like begin, statement 1, statement 2, statement 3, each of them separated with semicolon for the end of line, all within the begin and end, that's the curly bracket. The entire block is considered a single statement, composed of multiple sub-statements, as we can see. We have a generic statement that can either be a simple statement or a compound. Now, let's look at the if and else. Precisely this if statement first. Okay, the general syntax for if is this: if condition statement. Condition is the expression that is being evaluated. If this condition is true, the statement is executed. If it is false, the statement is not executed. So this is just a one-way if statement. This can be executed only if it is true. Okay. Now let's look at a simple example to demonstrate that. If x equal to 100, count x is 100. If x is not exactly 100, this statement is ignored and nothing is printed. The next one, look at this example. This statement shall be enclosed in braces, that's the begin and the end, forming a block. Unlike the previous one, now you look at this. If x equal to 100, then you have the braces, that's the beginning. Okay, C out x is C out x. It will print the value of x here. It will print x is 100, and this is the end of the if statement. Okay, you have if, then you have begin, then after the statement, then you have the end, just like in this case. Selection statement with if can also specify what happens when the condition is not fulfilled. This is done by using the else to introduce an alternative statement. If condition, statement 1, else statement. So look at the simple example that demonstrates the if and else. Now that we've seen how the if works, we get the syntax for the if else. Now look at the example now. If x equal to 100, see out x is 100. Else, see out x is not 100. If you look at the previous one, we don't have else, but this one we have else as part of it. Several if plus else structures can be concatenated for checking a range of values. For example, if x greater than 0, see out x is positive. Else, if x less than 0, see out x is negative. Else, see out x is 0. You can see here we are having several if, else, and else if, the combination of them. Okay. All right, the next thing that we're going to see now is what we call the iterations or loop. A loop allows the execution of a statement or group of statements multiple times. The general form of a loop statement in most of the programming languages indicated in this diagram. We have the condition. If the condition is true, it will operate what is inside the conditional code. Else, if the condition is false, it will operate what will be when the condition is false. We have different kinds of loop statement. Let's look at the other. The first one is the while loop. The while loop simply repeats the statement while expression is true. If after any execution of statement, expression is no longer true, the loops end. The program continues right after the loop. The general syntax for the while loop is while, then in bracket we have the expression, then we have statement. Let's look at the example to demonstrate. Wow. Look at this simple example. The first line is a comment, custom countdown using while. We have the hash include IO stream using namespace std int main. Int n equal to 10 while n greater than 10 while n greater than 0, begin cout n, then semicolon, then minus n. So in this place, what it will do is just that it will be printing the value of n and decrementing the value of n. Look at it. Let's check it. In the first instance, if you look at line 7, n is declared to have 10 at its value. And the loop said that while n is less than 0, it should print n. So in the first instance, our n is 10, it will print 10, followed by this comma. Then it will decrement the value of n, that's minus n. Once it's decremented, you will be having 9. 9 is greater than 0, yes, of course. Then it continues with what is in the loop. It will print 9, then print comma. It continues like that until it's printed 1. Then once it decremented 1 minus 1 is 0, then it will be 0. 0 greater than 0, this condition is false. Then it will go out of the loop and print lift off. That's why after 1 you can see the lift off appearing. Now we get the concept. The next one is the do while loop. The second one, it behaves like a while loop except that condition is evaluated after the execution of statement instead of before, guaranteeing at least one execution of statement even if condition is not fulfilled. The general format or the general syntax of the do while is do statement while condition. Now, you look at this simple example that demonstrates the do while. We have in the first line echo machine include IO stream include string using namespace std int main. You can see here string variable is declared str, and even the string is included as the header. Then here do begin cout enter text get line sin string. It will get the whole of the line whatsoever the user type. Then cout you enter whatsoever the user type, it will just print you enter what that user type. And the loop will only terminate if and only if the user type goodbye. Otherwise, it will keep on asking enter the text. Then it will tell the user you enter so text. Whatsoever the user type, it will just say you enter so text. And it will keep on doing this loop until and unless the user type goodbye. In that case, it will terminate the loop. Look at the example here. Enter text. Assuming the user just type hello, it will just print you entered hello. Enter text. The user type who's there. It will just print you enter who's there. Enter text. Now the user type goodbye. It will just print you enter goodbye and it terminates. Go out of the loop. Hope you get the concept. Okay. And the next one is the for loop. The for loop is designed to iterate number of times. The general format is for initialization, condition, increase, statement. That increase can either be increase or decrease. Okay. So let's look at that demonstrate the for loop using the countdown. Include IO stream using namespace in main. You can see here for int n equal to 10. N is declared and initialized to have 10. Look at the condition n greater than 0, n minus begin cout n, then it will print the comma, then out of the loop it will print lift off. If you look at this one, it's almost the same thing with the while loop that we just did earlier. And the first instance, it will check is n greater than 0. Of course, n is 10. 10 is greater than 0. Then it will print this one based on the condition. Then it will decrement the value of 10 to be 9. It continues in that fashion till it reaches 1, where it will be having 0. With 0 greater than 0 is false. Then it will become out of the loop and print lift off. Can you see that? Wow. Next one, under for loop, the 3 fields in for loop are optional. They can be left empty, but in all cases, the semicolon sign between them are required. For example, if you look at this one, semicolon n less than 10 semicolon is a loop without initialization or increase equivalent to a while loop. You can ignore the two, the first and the last. The other one, for semicolon n less than 10 semicolon plus n is a loop with the increment here, but no initialization. You can do it either ways. Maybe because the variable was already initialized before the loop. Before you enter into the loop, maybe the variable is initialized. In that case, you can do it this way. A loop with no condition is equivalent to a loop with true as condition. That is an infinite loop. You should take note when you are creating your loop so that you cannot fall under an infinite loop. An infinite loop is a loop that doesn't have an end. So one have to be very careful when he's passing a loop. Okay. The for can make use of the comma operator to separate multiple expressions. Using comma for a for loop to handle two counter variables, initializing and increasing. That's the good part of the looping, more especially the for loop. If you look at it, for n equal to 0, I equal to 100. We're having two initialization, two counter variables. Okay, then we are having n not equal to I. Can you see that? Then plus n minus I. At this time, we are having two variables that are initialized, and the condition is based on the two variables, and the two variables, one is incremented, one is decremented. Then whatever you want to type will follow. Get it? The next one is the break statement. The break statement leaves a loop even if the condition for its n is not fulfilled. Even if the condition for its n is not fulfilled, it can just break and leave the loop. It can be used to end an infinite loop or to force it to end before its natural end. For example, let's stop the countdown before its natural end. Look at it. All right. It's just the simple example that brings the countdown, if you could remember, from 10 to 1. So here we have our for int n equal to 10, n greater than 0, n minus, then C out n as normal. So this is what is introduced here. If n equal to 3, begin C out countdown aborted. It will just print countdown aborted, then break. So if you look at the output, it will be printing 10, 9, 8, 7, up to 3, after 3, then it will print countdown aborted and break. Nothing will come after 3. If, for example, our n is 7, it will stop at 7. 10, 9, 8, 7, then countdown aborted. Hope you get the concept. Okay. Apart from the break, there is what we call the continuous statement. The continuous statement causes the program to skip the rest of the loop in the current iteration as if the end of the statement block had reached, causing it to jump to the start of the following iteration. For example, let's keep number 5 in our countdown. Include IO stream using namespace std int main for int n equal to 10, n greater than 0, n minus. You look at it, it's the same countdown. So here you see if n equal to 5, continue. So what this one will do, it will just continue with its normal countdown. But if n is 5, that 5 will be skipped. That's why in the output you can see 10, 9, 7, 6. Is there any 5? Of course no. Because of the condition, if n equal to 5, continue. Once it is 5, it will just continue to skip that 5 and proceed. And the next one after 5, of course, is 4, then 3, then 2, then 1. So it's just like they are like kind of opposite. Break and continue. Okay. Next one is go to statement. Go to allows to make an absolute jump to another destination point in the program. The destination point is identified by a label. The label is used as an argument for the go to statement. A label is made of a valid identifier followed by a colon. Goto is a feature of low-level language used in C++. Let's see how we use. Look at the simple example here. Include IO stream using namespace int main int n equal to 10. See how the label is being initialized. My label, you can see the colon, then C out n, then semicolon, then n minus. You can see that? If n greater than 0, go to my label. As long as n is greater than 0, it keep on repeating this one. So this one is going to be inside loop for as long as n is greater than 0. And look at the initialization here. N is equal to 10. And of course, 10 is greater than 0. So it will keep on doing all this countdown until value of n greater than 0 is false. Then it will have lift off then. That's the same explanation with the previous. It will give the same output with the previous countdowns that we did for for loop and while loop. The only difference is this one we use different technique, different control statement. That's good. Okay. So what next? Next one is the switch statement. The syntax of the switch statement is a bit peculiar. Its purpose is to check for a value among a number of possible constant expression. It is something similar to concatenating if-else statement, but limited to constant expression. Okay. Look at it here. We have the switch expression, case constant, group of statement 1, then break. Case constant 2, group of statement 2, then break. It follows in that fashion. Okay. Then the default group of statement, although it's optional. Okay. Look at the explanation on the switch statement. Switch evaluates the expression and checks if it's equivalent to constant 1. If it is, it executes the group of statement 1 until it finds the break statement. When it finds this break statement, the program jumps to the end of the entire switch statement, the closing brace. If the expression was not equal to constant 1, it is then checked against constant. If it is equal to this, it executes group of statements 2 until a break is found. Finally, if the value of expression did not match any of the previously specified constant, the program executes the default label if it exists, since it is. Look at an example to demonstrate this. We have the switch example, we have the if-else example. Basically, they look alikes, they produce the same output. We have here switch x begin case 1, it will print C out x is 1, then it will break. Case 2, it will print x is 2, then break. The default value of x is unknown. Now look at the if-else statement counterpart of it. If x equal to 1, C out x is 1. Else, if x equal to 2, C out x is equal to 2. Else, C out value of x is unknown. This one, they will produce the same result with different approaches. Hope you get the concept. Okay. Now, another way to demonstrate the switch statement, you look at this example. Switch x begin case 1, case 2, case 3. Then C out x is 1, 2, or 3. Then it will break here. And look at the default. The default C out x is not 1, 2, nor 3. And that's all. And with this, we come to the end of today's class. Thank you for listening.